All right, mathletes, here we are looking at the cosine rule. So the cosine rule is going to be our tool that we're going to use to solve for side lengths of a triangle if we don't know its opposite side and an angle. So if we don't know these two things, so that we can't use the law of sines, we're going to use the law of cosines. So law of cosines is stated as such. Notice it kind of looks like the Pythagorean theorem here with a squared, b squared, and c squareds. Okay, and we'll look at how this is derived in class, but here we just want to understand how it's being used. Notice that these three equations, you don't have to memorize them, but you should recognize some patterns here. So notice that on the only thing on the equal side of the equal sign here is a squared. Well, that a squared is referencing our angle here on the cosine. The other two sides that we're dealing with, there's no other angles in here other than angle A, but the two sides, B and C, appear here next to our cosines. Okay, that pattern persists on this one. Since this is B squared, our angle is B. So what's left over? The A and C sides and A and C over here. And the same pattern for our C squared. You have angle C and sides A and B. A and B. Okay, so let's see this in action here. Okay, so find corrected two decimal places the length of BC. Okay, so if I want to find the length of BC, I'm going to label this side A because it's opposite my angle A. So I know that A squared is going to be equal to B squared plus C squared minus 2BC cosine of 38 degrees. Okay, so I'm going to plug in the other things I know. Well, I know I'm trying to find A squared. B squared is, so opposite of angle B. This is B, so then this must be C, opposite of C. So B is going to be 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 38 degrees. Making sure my calculator's in degree mode, I'm going to type all that in at the same time. So 12 squared plus 10 squared minus 2 times 12 times 10 times cosine of 38, and I get 54.2 decimal places. Well, I'm going to go to 3 because I'm not done, so I get 0.877, and this is equal to A squared, so to get A by itself, last step is to square root both sides. So then I get A is equal to the square root of my previous answer, and I get 7.41, and my units are meters. Okay, and that answer seems appropriate for this size triangle, with other sides being 10 and 12. A side length of 7 is plausible. So let's look at another example here. So find the measure of angle C in the given figure. So when we're finding an angle, what we're going to want to do is use the formula slightly rearranged. Okay, again, recognize the pattern. It's the same formula, just rearranged. So then if we're talking about cosine of A, the angle that's being, the side that's being subtracted is the one that correlates to the angle we're trying to find. And again, B and C there. Same thing, AC, and AB, where are angles B, so we're subtracting B squared. Our angle C, and you're subtracting C squared. Okay, so this is useful when we are given all three sides. So what we do is we don't know any angles of this triangle, but we do know the three lengths. So let's go ahead and find the measure of angle C first. So angle C, I'm going to want to use this equation here. So I get cosine of C is equal to, so label my sides, so this is C, this is B, and this is A, because they're opposite of their angles. Okay, So a squared, I get 12 squared, plus b squared, which is 14 squared, minus 11 squared, all over 2 times a times b. So on this one, on my calculator, I'm going to be careful. I'm going to do it in kind of 3 steps. First, I'm going to do my numerator. So I do 12 squared plus 14 squared minus 11 squared, and I get 219. Okay. On the denominator, I'm going to just multiply that out. So 2 times 12 times 14, and I get 336. Now that I have a simple ratio, I'm going to find a decimal expansion for that. So 219 divided by 336. And for this, I'm always going to go out to 4 decimal places. So I'm going to do 0.6518. Okay? And this is equal to my cosine of c. And just like when we were dealing with right triangles, if we want to find an angle, we're going to use our cosine inverse of our ratio, 0.6518, and we should get our angle. Okay? So inverse cosine of our previous ratio is going to give us an angle of 49.3 degrees. Okay, this is equal to our angle C. All right, that concludes our notes tonight. Please highlight any questions you may have and bring them to class tomorrow.